Hi everyone, thank you for having me. I am finally a PhD student working with Martin, and over the last few days we have been seeing that the number density of faint AGNs have been quite high. And over the next 5 minutes, I will try to answer a few not so simple questions, but what are the effects of these objects on reionization? Can you have a reionization model that is completely dominated by AGNs? And if so, what are the effects? So the way we do this is by running radiative transfer simulations. And because we're trying to study what AGNs do, we need these sources in our models. The implementation of these sources is shown on the right here. So on the blue are all the galaxies taken from a slice in our simulation at some random redshift. And you can see the red points, these are AGNs. So essentially what we do is we randomly select a bunch of halos to host an AGN, which is like a power law spectra. And then these objects emit ionizing photons for about 10 megayears before they stop that. And you have a different set of sources that are randomly allocated to now host AGNs. So in the end, you have this on and off AGN background and it changes every sort of 10 megayears. So the aim of these simulations, because we want to compare them to each other, we have to calibrate these models in some way or form. And essentially what we change is this ionizing emissivity. So as I mentioned, the aim is to match the mean Lyman alpha transmission, which I'm showing on the left. And our free parameter is this ionizing emissivity, which is why it has this strange shape of it increases and decreases again. So this particular example is for our fiducial model, which is this galaxy-only multi-frequency run. And we end up seeing that the ionization history for this model pretty much is what is standard in the field over the last 5 years. There's a late end to reionization, and it pretty much passes through most of the observation points. Accordingly, since the aim of this talk is to understand what AGNs do to reionization, we have a second model in which AGNs have about 20% contribution to the total emissivity. You can see that the mean flux is again matching the observations. This is by design, obviously, because we changed the emissivity. And the reionization history is pretty standard as well. We do see that there's a decrease of about a factor of 2 between the total ionizing emissivity if you have AGN-like objects, which is interesting in itself. Lastly, we have one final model in which all the ionizing emissivity is by QSOs. Again, the mean flux sort of fits the points. And you can see that the reionization history it doesn't really end by redshift 5, which might be interesting. So we have these three models. They're all calibrated to the same quantity, but there are clearly some differences. Are these differences major enough that we can rule out any model is the question. And the answer is sort of yes. So I'm showing the optical depth distribution, again, which was previously shown by Martin. On the left is the galaxy-only models, and the black points are the data. You can see that the galaxy-only models pretty much fit quite well. Towards the end of reionization, it doesn't have enough neutral regions to be right on the money, but it is well within the observational constraints. If you have AGNs, if you turn them on, you end up getting a better fit. This is essentially because AGNs are so good at ionizing the cells they're in. You have this potential of getting larger variation in the neutral and ionized regions. So you end up getting a better fit. But it kind of goes in the wrong direction if you just have AGNs. You get too wide of a distribution, so it doesn't fit at all. Another point that is usually spoken about when you talk about AGNs is this helium fraction. And excellent. The helium fraction for all of these models, the blue is the fiducial, red is when you have 20%, and yellow is when you have 100%, is that the helium-3 is only about 20% even when you have just AGNs, which is not too much. However, the temperature profile sort of is too high if you just have AGNs. So the QSO-only model, which is shown in the yellow here, just has too high of a temperature at redshift 5, and it's now starting to decrease. So given the few observations that I showed, the conclusion is that if you have AGNs, a moderate contribution fits the observational data pretty well. You don't really have to change your late reionization models. However, if you just want a QSO-only model, that is pretty challenging. The width of the distribution for the effective optical depth is too large, and the temperature is a little too high. So that's it. Thank you.
Thank you. Perfect.